This is a simulation of the kinds of experiments that scientists were doing at the beginning of the 1900s to try to determine what the arrangement of the electrons in an atom was. So here's a laser, and it's going to be shot at a sample of gas, which is inside a glass chamber. And then we have a detection system over here so we can see what kind of light is given off by the atoms inside this gas. There's a slider here so that we can change the amount of energy associated with the laser. And over here we have a model of the electrons in the atom. So that little red dot represents the electron, and the black circle in the center represents the nucleus. So I'm going to go ahead and fire the laser. And notice that that sample of light passes straight through the sample. I'm going to do it again. I'm going to do it one more time, and this time watch what happens over here in the atom model. So no movement for the electron at all. What if I move it up to 4 electron volts? Let's do it again. This time the electron moved. Let's watch that one more time. So the electron jumps and then releases some blue light and then falls back to where it was. Let's turn this up to 7. This time the electron jumps farther away and then falls back. Let's do that one more time. So it jumps farther away and gave off 2 different photons of light, first green and then blue. So look down here how it shows the energy of the photons that are emitted, and I want you to notice how that relates to the energy of the laser. Let's move this up to 10. Nothing happens. How about 13? Oh, so that time we got some movement. Let's fire it one more time at 13. That was a big jump out and back, 13 electron volts. So you have to fire just the right amount of energy. Now, would that be true for all samples? Let's go ahead and change our gas from gas A to gas B, and we'll go back and try all those again. So here's the 1 electron volt. Nothing happens. Let's go up to 4 electron volts. Nothing happens. Let's go up to 7. Nothing happens. Let's go up to 10. So all of these that worked the last time aren't having any effect on this sample at all. Let's drag this back down to 5 or 6. And notice 5 is an energy that affects this electron. So that tells us that each different kind of atom is going to be affected differently by different amounts of energy.